This is part 7 of the Craftsman Emerson 150 Drill Press Rebuild series. If you haven't seen part 6, click the link at the top of the screen. In this video, we'll be polishing some parts and modifying the quill. Hello everyone, I'm Jeff and welcome to my shop. We got a lot to cover, so let's get to it. Continuing where we left off in part 6, we've got these two halves of the split nut for the Jacob's chuck, and we're just wire wheeling the inside of them with this small brass wire wheel that I've got mounted in a Fordham, which is basically the same thing as a Dremel. And here we have the chuck body, and we didn't clean this up on the grinder wire wheel simply because it's got a lot of sharp edges, and that wire wheel on the grinder would have just grabbed it and slung it out of my hands. So we can do a little bit more of a precise cleanup with this small wire wheel and not worry about it getting thrown across the shop. Next, this is super slick stuff, and it is a penetrating oil. I love this stuff. It works great. And all those parts we cleaned up on the wire wheel in part 6, we're going to go ahead and coat. And this will keep them from rusting. So all the parts you see here, we'll just spray one side, flip them over, spray the other side. I use super slick stuff on all kinds of parts. If you saw my Reed 4C video, I coated that in the super slick stuff after I completely stripped it. So we're going to modify this quill. The quill on the left is the original, and the one on the right is from a 100 series drill press. They're basically exactly the same except for that channel. So we're going to cut that channel into the 100 quill. And that channel holds a retaining ring, and it keeps the quill from going too deep inside the head casting, which can cause all kinds of problems. And if you haven't seen my internal interactions video, I'll put a link for it here. And that video explains all of the reasons on why it's a bad thing if that quill goes too deep into the head casting. So it looks like we're roughly at 20.41 millimeters from the end. So we can call that 20.5 if you want. And it really doesn't matter if we go too far above that line. It's just we don't want to go any further below that line. So I'm coating the quill with this Sharpie so that we can see the mark we're going to make on it. Which this does the same job as, I think it's called layup or layout ink or dye. I'm not a machinist, so I don't have any of that stuff. Never used it. Sharpies have always worked for me. So we'll just lightly score a line here with the caliper or micrometer or whatever you want to call it. We'll just make sure that those lines match up, which they do. We're just using a 1, 2, 3 block here. So over at the metal lathe, I'm now going to measure the inside of that channel, the diameter of it. I don't have that caliper just right yet. So I think it's 39. I guess we can call it 39, somewhere between 39 and 40. As long as we're in there, we're good. So here I'm just using a cutoff bit, and we're just going to score that line. and cut that channel out. The problem is that we're on the wrong side of that line right now, and I don't realize it for a few minutes. So even if I had gone all the way down and cut this line out at the level it's supposed to be, it wouldn't have been the end of the world. But it doesn't look great. Yet another setback with this freaking drill press, man. But I haven't figured that out yet, so we're just making chips. Now my Chicom metal lathe is capable, but it's got a lot of nuances to it, so we got to kind of work with those. If this was a nice beefy vintage lathe, I could just plunge it in there and cut this out in one cut, but not on this lathe. So it's sometime around here that I realize that right here, hey, we're below the line instead of above the line. So we move the bit a little bit to the left here and start a new line. Like I said, we can go above, we just really can't cut below. So we'll just speed this up. We're going to go ahead and go all the way to the proper depth. Now, if you don't have a metal lathe, and you needed to do something like this, you could take it to a machinist and they could do it for you. So I think we're at the depth we need to be, but it's not a super clean cut in there. You can see how that bit was kind of chattering around in there. So we're just going to clean it up a little bit with a file. Just double, triple check our depth. We're at 38 point something or other, which is good enough for government work. Or so I've been told all my life. All right, so we'll just double check that with the original quill. Yep, we're good to hook. So next we're going to go ahead and polish this quill. And I'm just using some denatured alcohol to get that Sharpie off of there. We've still got a little bit of crud inside the gear rack on this thing, but we'll clean that out in a little bit. So because this is a part that slides through some bores, and the more metal we take off of it, the less accurate that drill press is going to be because there's going to be some play there. We're just going to be wet sanding it. So we start with, and we're doing this very lightly. So this is 320, and then we go to 400. Then we'll do 600, 800, and then 1,000 grit. And then I'm just going to use some Q-tips to clean up that gear rack. There's still stuff in there. We'll get it out of there though. And I'm just using that small wire wheel, this time on an actual Dremel. That definitely cleans all those indentations for that gear rack out of there. All right, continuing with the sanding or wet sanding. And we've rotated this quill now so that the cutoff end that we were working on is now on the left-hand side. We're basically doing the exact same process except for this last 1 inch, inch and a half down here, then evening all of that sanding out. Now, when you're wet sanding, just remember you've got to rinse between each grit. If you don't, then why even bother wet sanding? The whole purpose of sanding is to remove the scratches that the sandpaper makes from the previous grit. And if you're not rinsing, then you're not removing them. You're just adding more. So this is Mother's Mag and Aluminum Polish. And we're just going to apply it to the quill. And then we're going to use a ShamWow to buff it off of there. And then we'll rotate the quill one last time and get that last inch, inch and a half that was inside the chuck. And do the same thing. And we'll come back and clean out each one of those indentations in the gear rack with some Q-tips. And then we're done with the quill. We can set that sucker aside. All right, so the spindle that came with that quill, if you recall, we had to clean it up because I had mushroomed the end of it and stuff. And when I checked the run out on that thing, it was pretty bad. So we're back to using the original spindle, which is not in terrible shape. It's just the whole spline area is really pitted. So we're going to clean it up. And here we're just using the wire wheel to clean up the splines. And a little bit around that thrust collar. And then we'll take it over to the vise. And because that stuff is so pitted, you can see all the pitting there. The spindle pulley assembly does not want a seat on it. So we're kind of back at doing what we did in the last video. We're going to have to break out another file and do some filing. You guys might hear my wife upstairs banging on the floor for some reason. So this is basically the exact same thing we did in the last video. Once we get all of those two parts working properly, then we can move over to the metal lathe. And here we're going to remove a little bit of material on the outer edge of the splines. Simply because it looks like crap. But hopefully it'll assist a little bit in allowing the spindle pulley assembly to slide on it a little bit more smoothly. We really didn't do a whole lot there. That pitting is super deep. So now we're just going to polish the rest of the spindle. And we're doing the wet sanding again. So again, we're doing 320, then 400, 600, 800, and 1,000. Rinsing between each grit. And we're not going to really do anything with the end taper there. Or if we touch it, we're just barely touching it. All right. So here we're going to go ahead and mount the chuck body to the thrust collar on the spindle. And then we're going to polish the chuck body. So you can see those sharp edges on that middle section. And that is what will grab stuff right out of your hand if you're not careful. So what we're going to do is we're going to do some dry sanding, and then we'll do wet sanding, and then we're going to polish it with the mag and aluminum polish. So for the dry sanding, I think we're going to start with the 100. So we'll do 100, 120, 180, 220 for dry sanding. And there's no rinsing or anything like that between the grits. And whenever I'm working with that little middle section there, I've got the sandpaper just barely in my hand in case it grabs it and yanks it. I don't want it to grab and pull my hand into it. So like I said, this is not for the faint of heart. And then we're back to wet sanding, and for wet sanding, again, we're using that 320, 400, 600, 800, and 1,000 grit. And we're not using the rag to wet that middle section because it will definitely yank that rag out of our hands. And then we're actually doing a little bit of sanding on the inside, those two cutouts that the one that the split jaw rides in, and then the other one is kind of just an overflow area for the back side of the jaws themselves. And once we've got all that sanded up to 1,000 grit, we'll dry all that off. And then we will apply the mag and aluminum polish. And then we will polish it and buff it off with that ShamWow. Then we'll clean up any of the excess polish we have with some Q-tips. And wipe everything down again. We can remove the chuck. All right, the next thing we're going to do is we're going to check the run out on this spindle. So where the jaws on the chuck are on the spindle, that's where the bottom bearing sits. And normally if you have run out in the spindle, it occurs between there and the taper. So here we'll just zero out this dial indicator. And then we'll rotate the chuck, or the chuck and the lathe. As you can see, we've got about 1.5 thousandth, which is pretty good. For drill presses, it's, I guess, an industry standard that anything better than 4 thousandths run out is a decent drill press. But I like to keep it below 2 if possible. And I'm checking this at multiple areas on the taper because we're not sure where the chuck's going to grab onto that taper. And again, we are at 1.5. And I've got a video on how to check your run out and some ways of correcting it, and I'll put a link for it here. So next we have the sleeve for the Jacobs chuck. We're just going to polish it. So we're going to put it in the lathe. All right, and we're just going to wet sand it like we did everything else pretty much. Again, we're doing the 320 and then the 400, 600, 800, and 1,000. And we're rinsing between each grit. Just be careful about those teeth that are on the right side as we're looking at it, especially when you go to rinse. If you're using a rag, those teeth can grab it. So once we got it sanded, then we're going to go ahead and apply the mag and aluminum polish. And then we'll clean up any of that excess polish with the Q-tips. I like the look of the older chuck styles with the paneled sleeves and the paneled safety collar, but the newer style that are just solid without the panel lines on them, they polish up nicer, in my opinion. So here, we're back at my Fordham, and we're just going to buff some of the bores and some of the lower areas on the chuck body. I'm just using a little cotton buffing disc on my Fordham. We'll clean out the socket a little better. And we'll clean out those recessed areas that we were talking about. And that's going to wrap up this video. I hope you enjoyed it. If you did, please like and subscribe. In part 8, we will continue working on this drill press. So, it's kind of, to me, it's felt like for every step forward, we've taken 2 steps back on this thing. But, yeah, we'll get it done. We'll get it running. We'll have a nice drill press when we're done with it. So, as always, I appreciate the support. If you got any questions or comments, leave them in the comments section below. Don't forget about the links. I've got links for the owner's manual for this drill press, as well as the motor and all that good stuff. And links for some helpful web resources for the drill presses down in the description of the video. And as always, I will see you next time.